Hi there, let's try to get you guys caught up so you can do well on the check-in. Here we go. Here's the big part. We got to figure out this pattern. We're going to start with a pattern right here. You see it, step 1, step 2, step 3. We're going to build a table for it. That table will help us find the recursive rule, help us get from step to step. That recursive rule will take us back up here to identifying groups, how we're going to circle certain groups of blocks to try and figure out how this pattern works. Those groups will help us create expressions. Those expressions will then help us create the explicit rule. And then it'll take it right back to what we did in the beginning. When we explain a representation of thinking, we're going to go right back to how we group these things and figure out exactly what our explicit rule means to our understanding. Then that explicit rule is going to help us answer two questions. The first one being here, how many blocks will there be in the 231st step? You certainly don't want to bring this out to the 231st step. That would be a lot of blocks. So hopefully that explicit rule will help us get there. And then another question, is there a step that has exactly 723 blocks? Meaning if you drew this out, is there a step that has 723 blocks? And if there is, what step number is it? And if not, how do we explain why there wouldn't be a step that has that many blocks? Okay, the first thing we want to do here is literally count how many blocks are in each step. Hopefully the counting will lead us to a pattern. That pattern will help us fill out this table. The two items that we're trying to relate together are n, which represents simply the step number, and b, the total number of blocks. Total number of blocks. Please excuse my handwriting. It's hard to do with my finger. As you can see, we have step 1, step 2, step 3, so I'll put that on my table. 1, 2, 3. We're going to add 4 and then jump up to the nth step, hopefully. Alright, so how many blocks are in step 1? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's simply 9 blocks in step 1. Step 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 blocks in step 2, and now I'm starting to see a pattern here. If this grows in the way that all these patterns have been, to get from 9 to 13, all I have to do is add 4. So to get from step 2 to step 3, again, I will add 4. 13 plus 4 gives me 17. And if I'm not quite sure, I can just count and check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Sure enough, without drawing step 4, I can certainly figure it out. 17 plus 4 gives me 21 blocks. The table helps me understand the recursive rule for this pattern. Alright, certainly the recursive rule helps us get from step to step, and to get from step 1 to step 2, or from step 2 to step 3, or from step 3 to step 4, or from step 21 to step 22, all we have to do is add 4 blocks. To each last step. The key number here is to add 4 each time. Okay, here we are. We're going to start to identify the groups, which people have a hard time doing. But luckily, in the last bit, we found that the recursive rule was to add 4 each time. That is going to help us group these. I either want to look for groups of 4 or 4 groups of something. I'm going to choose the first one. I'm going to look for groups of 4. Alright, so the first thing I see is that I've got 1, 2, 3, 4 blocks right here. That is one group of 4 blocks. There are 1, 2, 3, 4, 5 blocks left. I could certainly do another group of 4, but I am in step 1, and it's nice when something matches the step number. And here I have a group of 4, and 4 definitely doesn't match the step number, but there is one group of 4, and that one group matches the step number. Again, the one group that I circled matches step 1. Alright, so in step 2, I'm going to circle another group of 4 and another group of 4. And again, each of these groups has 1, 2, 3, 4, 1, 2, 3, 4, but notice there is one group, two groups, because I'm in step 2. Now the other thing I notice about this when I start to do this, one group of 4 left 1, 2, 3, 4, 5 blocks remaining. Two groups of 4 left 1, 2, 3, 4, 5 blocks remaining. So each step, when I'm grouping 4, I have 5 blocks remaining. The last step, I'm still going to stick with this pattern of grouping 4. There's one group of 4. There is two groups of 4. And there is 3 groups of 4. Why 3 groups of 4? Because we're in step 3. One group of 4, 2, 3 groups of 4. And lo and behold, 1, 2, 3, 4, 5 blocks remaining. Okay, now that I've grouped in groups of 4, this will help me start to create expressions that represent the total number of blocks in each step. Again, let me say that again. The total number of blocks in each step. Okay? In step 1, I have one group of 4 blocks and 5 uncircled. In step 2, I have two groups of 4. So we will write 4 times 2 plus the 5 that are remaining. And in step 3, I certainly have 1, 2, 3 groups of 4. So I will do 4 times 3 plus, again, the 5 that remain. And hopefully you can start to see a pattern in your expressions. Every time there's a 4, and that 4 represents the number of blocks in each group. The 1 here represents that there's one group of 4. The 2 represents that there are two groups of 4. The 3 represents there are 1, 2, 3. So these numbers that are changing represent the number of groups. And look at that, they're the same as the step number, which makes things very, very easy. And of course we have this plus 5, and you can easily see that in each step there are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 blocks that remain uncircled. Writing an explicit rule for this is as easy as looking at the expressions that you made. Certainly the things that stayed the same was that there was always groups of 4. What changed was the number of groups. What stayed the same was that there was always 5 blocks remaining. So what do I represent for that number that is always changing? Well, in step 1 there was one group. In step 2 there was 2 groups. In step 3 there was 3 groups. So for the nth step, I know there's going to be n groups. And that, ladies and gentlemen, is our explicit rule. 4 times n plus 5. Let's not forget to annotate our expression that we just came up with. Certainly the 4, if you looked at our groups, represents the number of blocks in each group. n, the variable, the most important thing to name here, represented, in this case, the way we grouped it, the number of groups. And then 5, we always added 5 because those were the blocks that were uncircled every time. That explicit rule will really help us here, if you remember. 4n plus 5. Bringing it back to the table here, 4n plus 5 was the same thing as b, the total number of blocks. So again, we have two things that we're relating. B, the total number of blocks in some number step, and n, whatever step you're talking about. So when a question asks how many blocks will there be in the 231st step, you really have to ask yourself, what does the 231 have to do with? Is that the number of blocks or the step number? And if you read it again, how many blocks will there be in step 231? This is step 231. So that really is an n. So if n equals 231, how do we use this equation? Well, I rewrite it. B equals 4 times 231 plus 5. Instead of writing the n, I'm going to replace it with what n is, 231. Using our expression, we get a very abstract looking number, but we understood that there were 4 blocks in each group, and this time there are 231 groups, and of course we have to add 5. So, 4 times 231 is 924. Plus the 5 gives us a total number of blocks of 929 blocks in step 231. Still going to use our explicit equation. Let me write that again now. B equals 4n plus 5. To answer this question, is there a step that has exactly 723 blocks? Mathematically show how you arrived at your solution. The math is going to be through the explicit equation. Again, I ask myself, what is 723? Is it a block number or a step number? And certainly you can see here, it is a block number. So if I rewrite my equation, instead of b, I'm going to write 723 equals 4n plus 5. Let the algebra games begin. We're trying to solve for n. We subtract 5 from both sides. 723 minus 5 is 700 and 718 equals 4n. All we have to do now is divide both sides by 4. And we just ask ourselves, does 4 go into 718 evenly? Goes in once for the 7 times 4 with 3 remaining. Goes in, let's see, 7 times. There's a 28. And that's a minus 3, 38. Well, 4 goes into 38 definitely 9 times. But that leaves you with 36 with 2 remaining. So 79.5. 4 times 5 gives you 20. And we certainly look at that quotient here. What that means is we have really step 179.5. But if you take this all the way back to the context, what this means is that there isn't a step that has 723 blocks, because there isn't a step that looks like 179 and a half. There's certainly the 179th step, And there's the 180th step, but there's not the 179.5 step. All right? Just sounds kind of funny because the step numbers have to be integral or whole number steps. So our answer is there is no step that has 723 blocks. Certainly the math, especially this equation that you set up, shows understanding of you trying to figure out whether there is a whole number solution that would give us a step number that would have 723 blocks. But since this was not a whole number solution, there is no step that has 723 blocks.